we check the assignment method, we actually understand how is the procedure, essentially the Hungarian procedure for assignment. We understood that this procedure have essentially two phases. Phase 1, row and column reduction. You subtract the minimum value of each row from the entries of that row, and you subtract the minimum value of each column from the entries of that column. Then you jump into the phase 2, which is the optimization of the problem. Remember that the idea is to drag the minimum number of lines to cover all the zeros in the matrix. How do we do that? With row scanning, with column scanning. If we are able to actually cross all the zeros, we need to check if the squares are equal to the number of rows and columns. If so, you actually finish. If not, you need to identify the minimum value of the undeleted cells, add that minimum value to undeleted cells at the intersections, subtract the minimum value from the undeleted cells, and keep the rest the same. So with the couple of exercises, actually you also have a homework. I think we stop at this slide, number 38. Let's see another exercise, or other exercise but without diagonal assignment in this case. Let's say that for some reason, okay, I do not want to assign a specific, it could be operator to a specific job. So here you can see a line, because I don't want the task number 1 to be assigned to the operator 1. So I draw a line here. And this is the cost matrix. Remember, could be cost, could be distance, could be time. This is a symmetric matrix. So the cost of 2 to be assigned to 1 is 6. 6, 1, 1, 7, 6, because it's symmetric, okay. Actually, you can see it here. So it's the same. You see the first row, dash 6, 1, 1, 7, 6. Here the dash has been replaced by an infinite. Because remember, because we do not want 1 to be assigned to 1, we can replace that line with an infinite symbol. Why? Why I cannot I do not want to assign 1 to 1? Because for some reason, right now it's not clear. For some reason you do not want to do that. Let's say that you do not want to assign the task number 1 to the operator number 4. What should you do? You can actually replace this one by an infinite. And because the procedure minimizes, this assignment is not going to be assigned actually. You are not going to assign 1 to 4 because you have an infinite there. And you're minimizing. So it will not assign. Okay. Later on, you will see why we could have a matrix like this. Right now, do not worry about that. So somebody tell you, do the Hungarian algorithm for this matrix. Do not pay attention to the reasons why. Okay? So you can follow the procedure. What is the procedure? Step 1. Subtract the minimum value of each row. What is the minimum value of the first row? 1. What is the minimum value of the second row? 3. 1, and so on. So you can extract start subtracting. Infinite minus 1, infinite. 6 minus 1, 5. 1 minus 1, 0. 1 minus 1, 0. 7 minus 1, 6, and 5. So this is the matrix after the subtraction. Infinite, 5, 0, 0, 6, 5. Infinite, 5, 0, 0, 6, 5. Is that clear? The same for the second row. The minimum value is 3. So 6 minus 3, 3. Infinite minus 3, infinite. 5 minus 3, 2, 2, 0, 1. 3, infinite, 2, 2, 0, 1. So is it clear? How did I arrive to this matrix? At this point, we have completed row reduction. Now let's go into column reduction. What is the minimum value of the first column? 0, 0, 0, 0. Here is 0 also, and here is 0 also. So after column reduction, my matrix is not going to change. So I need to start doing row scanning and column scanning. So let's do that. Let's do row scanning and column scanning. Let me jump into the breadboard. Any questions? Any questions so far? So how do we do the assignment? Let's scan the first row. And remember the question. So this exercise also helps us to remember the procedure. We have to ask ourselves, is there exactly 1 0 in the first row? No, I have 2 zeros. Is there exactly 1 0 in the second row? Yes, so square that 0 and draw a vertical line. Is there exactly 1 0 in the third row? Yes, vertical line. 1 0, no. Is there exactly 1 0? No, skip. Is there exactly 1 0? No. Are all the zeros covered by lines? No, so I need to do column scanning. This column is already taken. Jump to one. Is there exactly 1 0? Yes. So erase that row. Is there exactly 1 0 here? Yes. So you should erase that row. For column, is there exactly 1 0? No. No. We finished that. Are all the zeros covered by lines? Yes. Is the number of squares equal to the number of rows? The answer is not. So I need to identify the minimum number of the undeleted cells. So what is the minimum number of the undeleted cells? In this case is 1. So I need to add this 1 into the intersections, subtract this 1 from the undeleted cells, and keep the rest the same. So let's add. Infinite plus 1, infinite. 6 plus 1, 7. 4 plus 1, 5. Infinite plus 1, infinite. So let me return to the presentation. So after my scanning, I need to add. So you can see how this infinite keeps his infinite value. This 6 turns into 7. Good. Row number 5, column number 1. This is going to increase to 5. Row 5, column number 1, 5. Look at this. Infinite is going to be infinite. What else? Here, identify this region. This region is undeleted, so you need to subtract 1. So this is going to be infinite 1, 1, 3, infinite 0, 3, 0, infinite. Infinite 1, 1, 3, infinite 0, 3, 0, infinite. You see? This region also is going to decrease 1. So it's going to be 0, 1, 3. 0, 1, 3. This region also is going to be 0, 3, 5. 0, 3, 5. The rest is going to keep the same. For instance, the first row is going to be the same, except in the intersections. It's going to be 5, 0, 0, and 5. 5, 0, 0, and 5. Is increased to 7 because you have an intersection there. Is there any questions there? Hopefully everybody understands how do we jump, or how do we do the add, subtract, and keep procedure. So at this point, let's do the assignment. So let me copy this to jump into the breadboard and do the assignment. So the same row scanning. Is there exactly 1, 0 here? No. Is there exactly 1, 0 here? No. Is there exactly 1, 0 here? No. What about this? No. What about this? No. What about this? No. And was covered by lines? No. So I need to do column scan. Is there exactly 1, 0 here? No. Is there exactly 1, 0 here? No. No here. No here. No here. No here. What should I do? Identify the minimum number of the undeleted cells. What are the minimum numbers of the undeleted cells? 0. Add this number to the intersections. I do not have intersection. Subtract this number. Essentially, it will not change. So what is the answer? What is the meaning of this? You can tell me what is the meaning of that? Marco Urquango. Do you know what is the meaning of this?
Repeat my question, teacher. I have
You don't know. Who knows? Somebody knows.
You have to apply the diagonal.
Yeah. I have to do the diagonal. But what is the meaning of the diagonal? What
It has multiple solutions.
There are multiple.
Yeah, that's the meaning. Okay, the meaning is that you have multiples. That's the meaning. So I will do diagonal. Okay. If in the assignment I am not able to complete, I repeat again, because sometimes you are not able to arrive to a solution, so you repeat again. So let's try. If not, you know, I need to repeat. So let's do. Scan the first row. You have two options. You can choose whatever you want. Let's say that I choose this one. So you eliminate the column. The next one. Remember that you need to try to assign the diagonal. So I can do this and eliminate this. What about the next? I only have one option. What about the next? I only have one option. What about the next? I have two options. Let's do this. What about this? I can eliminate this. And finally, no. Are all the zeros covered by lines? No. So here, you see how I cannot arrive to a solution. Maybe in the last step, instead of choosing this 0, maybe you can choose this here. So the moment that I scan row number 5, instead of choosing this, let's choose this. Finally, I only have one option. Do you see how I have arrived to a solution because I have made 5 assignments. Okay. There is not the only one solution. Maybe somebody can start assigning from this point and arrive to a different solution. So the final solution is 1 to 4, 2 to 5, 3 to 1, 4 to 3, 5 to 6, and finally 6 to 2. Okay. Is there any question about this? Don't be afraid to ask. The idea is to have questions so we can answer.
Professor, so the infinite could I locate or put in any place that I need?
Yes, in any place that you do not want to assign. Okay. Instead of infinite, let's see if you are using a computer also. Instead of putting an infinite, you can essentially give a high value also. So instead of infinite, you could use 100. Okay. So it will produce the same effect. But if all the numbers here are in this order, maybe you can use 1000 or 1 million instead of an infinite value. Whatever assignation you do not want to do.
I have another question, Professor. Can you repeat the diagonal process, please?
Of course.
Thank you.
Actually, let's repeat everything and let's choose a different path. So because I have essentially run out of my algorithm, I will start doing my diagonal assignment, okay, from this point onwards. And remember the diagonal assignment. You scan the first row, you have 2 options. You can choose whatever you want. Last time we chose this one. Let's choose this one. So let me choose this one. So because I am scanning the first row, I can eliminate this column. What about the second? In the second row, I have 2 options, either this or this. Let's choose this. So I eliminate this column. The third, where my rule actually tells me to choose diagonally. So let's try to choose this one. The fourth, I only have 1 option. Fifth, what should I choose? I suggest you choose this one. Because if you choose the second, you are going to have problems in the last assignment. Look at this. If you choose this one, okay, then you finish and you are not able to assign this value, because if you assign this one, what happened? Task number 5 is assigned to 6, but task number 5 was already assigned to 2. Okay, so it's not a good option to choose this one. So let's choose this one. In that way, I can choose this one in the last step. And I have completed my assignment. I arrived to another solution. But the 2 solutions that I arrived, this one and the last that I just finished recently, are both optimal. Both have the same value.
Okay, thank you very much.
Okay. So you need to do this again and again. Repeat the assignment until you arrive to a solution. If you have problems, erase everything. If you did not arrive to a solution in a test, erase everything and start again. Repeat up to the point that you arrive to a solution.
Professor, I have a question.
Mm-hmm.
In this example, we have a diagonal line of infinitive symbols. It means something.
What?
This line means
What's
something special. For example, the characteristic about the matrix or something like that.
I don't want to mention about that, but let me mention. Later on, we will be like assigning machines to machines, and this is going to represent distance. So I want to make groups of machines. So I want to assign machines to other machines. Later on, we will learn that. But I do not want to assign machine 1 to machine 1. So that's why usually in that procedure, I replace that value with an infinite. So I do not want to mention that because at this point you are not going to understand what I am talking about. Okay. Just for that reason, my suggestion was just think that somebody give you this matrix. Can you solve? Yes, because at this point we are just learning assignment methods, and we know how to proceed to procedure. What is the procedure for the assignment method? Specifically the Hungarian method. Okay, don't worry about this infinite. Is there more questions? Are there any other questions? So here I have another solution, I think. All of them optimal. This was the beginning of the problem. Here we are solving a 6 by 6 matrix. What if I want to assign a specific task? I want this task to be done by this operator. So I want this assignment actually be done. So I assign at the beginning. Eliminate this, and I eliminate this. I only solve, instead of solving a 6 by 6, I solve a 5 by 5 because I have a preference. I want this job to be done by this worker because this worker is very good at doing this job. So the problem is just essentially a 5 by 5. You know, you just need to eliminate this, and you just need to solve the rest, the 5 by 5. Hopefully that is clear. That is also something that could happen. You have the information, the full information, but you also have one work to be done by one operator. So essentially, you do not have a 6 by 6 problem. You have a 5 by 5 problem because one of them is already assigned. What if I want to maximize? Remember this problem. This problem was, we already solved this problem in the last class. We have these 5 jobs and these 5 operators. And the objective of the procedure that I just explained to you is to minimize. The procedure always minimizes. But what if I want to maximize for some reason? I can think in infinite ideas because I want to maximize. Maybe these are profits. Maybe this is the quantity of money that I earn in each one of the jobs done by these operators. Okay, so if it is profit, I want to maximize the profit of my factory. Okay, So how do we maximize? So the idea is very simple for maximizing. The idea is just to choose the maximum number of the matrix. What is the maximum number of this matrix? Is 15. So you need to subtract from 15 all the values of this matrix. So you need to create a new matrix, a new 5 by 5 matrix. So this matrix is going to be 5 by 5. But each one of the elements of this 5 by 5 matrix is going to be the maximum number minus each one of the entries. Okay. So this is going to be 15 minus 9, 6. 15 minus 11, 4. And you do the same. So if you want, we can do that. So let's do that, just to see. I can copy that matrix to my breadboard. Here it is. So because my objective is to maximize, so I'm going to identify the maximum number, in this case is 15, and I will create a new matrix. So this new matrix is going to also be 5 by 5. But the first element is going to be 15 minus 9, which is 6. Let me switch colors. 6, 4, 1, 4, 8. Next one. It's going to be 9. It's going to be 0. Going to be 2, 2, and 5. So the next one, 3, 2, 9, 7, 7. What about the next one? 4, 6, 5, 3, and 6. What about the next one? I think it's the last one. It's 8, 3, 1, 5, and 1. And from this point onwards, you essentially proceed the same. So what is the first step? Identify the minimum value of each of this row is 1. The minimum here is 0. The minimum here is 2. The minimum is 3 and 1. So you need to subtract. So if you subtract, your new values are going to be 5, 3, 0, 3, 7. The other is the same. The other is 1, 0, 7, 5, 5. Next one is going to be 1, 3, 2, check, 0 and 3, 7, 2, 0, 1, 4, and 0. We have finished row reduction. Let's do column reduction. What is the minimum of this column? Is 1, 0, 0, 0, and 0. So the only thing that's going to change is the column number 1. It's going to end up with 4, 8, and 0, 0, and 6. The rest is the same. 3, 0, 0, 3, 2, 0, 2, 7, 2, 0, 3, 2, 5, 0, 4, 7, 5, 5, 3, and 0. So we will work over this matrix. So let's scan the first row. Is there any, is exactly 1 0 in the first row? Yes. Is there exactly 1 0 in the second row? Yes. Is there exactly 1 0 in the third row? Yes. Is there exactly 1 0 in the fourth row? Yes. Is there exactly 1 0 in the fifth row? Yes. So I have completed my assignment. It means that job 1, operator 3. Job 2, operator 2. Job 3, operator 1. Job 4, operator 5. Sorry, 4. And job 5, operator 5. So you should return to the original matrix to see the final result. Because if job 1 is done by the operator 3, what is the time or cost that it will take? 14. You see, actually it chooses the higher one. The number 2, 15. 3 doing the 1, 12. It doesn't choose the 13, but for some reason this is already occupied by another entity. Number 4, 12. 5, 14. So maximum number what is? 14, 67. So this is the maximum number that we can get if we need to maximize or minimize. Okay, that's the procedure for the maximization. Remember, always this procedure minimizes. For that reason, if we want to maximize, we just subtract from the maximum value each one of the entries. We change the matrix. And then we continue the same. We arrive to the maximum. Questions? So if not questions, let's have a 10 minutes break. So let's take a cup of coffee. Okay?
If I could assign one operator to one job or one machine to other machine, we couldn't use infinite. We maybe use a 0.
If you enter a 0, it means that you are actually forcing the assignment, because the zeros are the places where you are going to assign. Okay. If you put an infinite, then you are actually preventing the assignment. So if you want the job number 1, if you want the job number 1 to be done by the operator number 4, maybe you can enter a 0. Then you are forcing this assignment. If you do not want the assignment, then you put an infinite or a higher value. like 100, like 1000. Hope I understood your question.
Yes, but if I want to maximize, I first have to select the maximum number and then put the infinite.
Okay. Let's see that you have nothing in an infinitive. Let's do the explanation here. Here. Let me erase this. This is a good question, actually. What is the maximum number here? It's infinite, really?
Yes.
But it will not work. So instead of infinite, you can use actually 100 here. 100, 100, which have the same effect. So then your maximum number actually is 100. You need to subtract this from each one of the entries. So your new matrix is going to be 0, 100 minus 6, 94. Okay, 99, and so on, and so on, and so forth. And you solve. Maybe the assignation is going to be 1 to 1, 2 to 2, 3 to 3, 4 to 4. Why? Because in that way you maximize. You know, maybe your value is going to be very high with this assignation because you have a lot of zeros here. So the moment that you scan the first row, this assignment. Oh, sorry. Second row, this assignment. Third row, this assignment. So the assignations that you are going to end up with is just the diagonal. Yes, because that is the one. In that manner, you actually get the maximum number. Got it?
Yes.
Okay. So let's have a 10 minutes break. We'll return at 3 plus 10. Let's take a cup of coffee and return. So let's continue. So how can we use Excel for solving this problem? We want to minimize this distance. Can we use Excel? So let's open an Excel sheet. So we can also do that. Let's copy this matrix, the Excel sheet. So here you have the jobs. 1, 2, 5. Here you also have the operators 1, 2, 5. Okay, so here is 9, 11, 14, 11, 7, 6, 11, 9, 10, 12, and 9, 7, 12, 14, 10, and 14. I could also copy this, Ctrl+C. Here erase this. And here we are going to calculate the total cost. So total cost. So what could be the function to calculate the total cost? The function could be, in Spanish, suma producto. With this command, you select, as you can see here in the format, a matrix, comma, another matrix. So this matrix, comma, another matrix. So imagine if 1 is assigned to 2, you can enter a 1 here. And you see that the total cost is 11. If 1 is assigned to 4, the total cost is 22 because 11 plus 11. What about if 4 is assigned to 3? You can enter a 1. It means 22 plus 10, 32. You see? In that way, this matrix actually is counting the assignment. If you enter 1, it will keep increasing. Okay. So the idea is to have a robot or a computer that can start changing these numbers. So instead of 1 here, maybe it could be a 0, maybe the 1 could be here. If it is empty, it's the same as a 0. We want a machine to start trying to try different values here until up to the point it minimizes this value, this total cost. How can we do that? But also remember, the robot cannot actually assign 1 and 1. You cannot have 2 ones in the same row. That is wrong. Okay, so you can count that if you enter the sum. If you sum all of these, let me increase the size. You see, you cannot have a 2 here. Similar in the vertical direction. You can also use a sum command for this column. And essentially you can repeat the same for the rest of the columns. Let me increase the size. Make it bold. Here I cannot have a 2. I cannot also have a 0. I need one assignment in this column and also in this row. I will have a 1 here. That is a feasible solution. Here is not a feasible solution, so maybe I can enter a 0 here. Oh, this is a feasible solution. Look at this. 1 to 2, 2 to 4, 3 to 1, 4 to 3, 5 to 5. But the question is this the minimum value? Instead I assign a 1 here, 0 here, maybe, I don't know, I cannot do that, so let me replace another 1 here, whatever. You know, we need a robot or a program that start changing these values. So what is that robot? So the robot is going to be the solver here in the data tab. You see here the solver. If you do not have the solver up here, maybe you can enter into file and go to options, complements, and then you need to select solver, and then you just click in upload. Okay, it's not difficult to add the solver if you do not have that in your Excel sheet. Once you have the solver here, so let's click in the solver. So let's click into the solver. Let me arrange a little bit better. So let's click solver. First question is, what is your objective? So click here. My objective is this cell that is turned into a green color. What do you want to do? Maximize or minimize? In this case, I want to minimize. Okay. What cells do you want to change? I want you, machine, to change these cells. Okay. What are the restrictions? What are the restrictions? Okay. The first restriction is that this value here should be 1. Not only that, all of these all of these should be equal to 1. And then you hit add. What is another restriction? Another restriction machine is that all of these should also be equal to 1. Another restriction is that all of these values should be binary, either 1 or either 0. So I choose binary and add. I think that's all. So I have completed. So let's recap. You should identify what is your objective. What do you want to do? Minimize. Changing what values here, this matrix. I want to change, but with some restrictions. All of these values should be binary. And also the summation, these cells here, should be equal to 1. Also, all of the summation of the columns should be equal to 1. So at this point, you can hit this button, solve. And you have arrived to a solution. Do you want to keep the solution? This is the solution. Let's accept the solution. So the solution right now is this matrix. 1 to 5, 2 to 1, 3 to 3, 4 to 1, 5 to 4. And the final objective, if you minimize it, is 38. Actually, we solved this exercise. Let's compare. The last class we solved this exercise. It was the first exercise that we learned. This was the first exercise. After we complete all of these steps, we arrive to a solution. The final solution was 1 to 5, 2 to 1, 3 to 3, 4 to 2, 5 to 4. Let's compare. 1 to 5, 2 to 1, 3 to 3, 4 to 2, and 5 to 4. You see, it's the same solution. Because actually this problem have just one solution. This problem doesn't have a multiple solution. This only have one solution. So our solver was able actually to arrive to the solution. What if I want to maximize? Let's try to maximize this. So the same. Now this time I only need to change this into max and solve. Except, let's repeat. Let me try it again. The objective is this. The idea is to maximize, changing these variables. Okay. So let's erase this. Sometimes it doesn't work because it starts from one solution. So it's a good idea to actually reset this. Let me, just in case, let me reset this. Let me put everything into 0. Let's try to reset. Zero, zero, zero. Okay. Some numbers here like 1. I'm starting in a different point. Let's try to solve. It's my objective is I want to maximize, changing these variables, What are the restrictions? Restrictions are that these cells should be equal to 1. Also, these cells should be equal to 1. Also, these cells should be binary. Okay. Except okay. Also, you can change trying to reset the solver if you do not have a good answer. Let's try with this GRG nonlinear. So solve. Now the final solution is 1 to 3, 2 to 2, 3 to 1, 4 to 4, 5 to 5, with the final objective of 67. With our solution, the moment that we maximize, I think we did the maximization here in the bracket. Yes, this was 67. Remember? 67. So that's the way you can use Excel to solve these problems instead of doing it manually. Because sometimes you can have some difficulties to do it manually, especially if the matrices are very big. A big matrix could be problematic. So one option that I am giving you is to use the solver. If for some reason you do not arrive to a solution, maybe you can try changing the method of solutions. You have a lot of different methods. So you can use the simplex method or a method that is evolutionary and will arrive not to the optimal solution, but you essentially set up a time and the machine will start changing until it chooses the best one, something like that. So you can give it 5 minutes to calculate and stop after 5 minutes. Those are the options that I am giving to you to solve these problems. Okay, questions?
Yeah.
Okay, what's your question?
Could you repeat how to add the solver complement?
Yes. You go here into File. Sorry that I have in Spanish these options. Complements. You should have a solver here. And you need to hit Go. Here you should find a Go. And then you accept. In that manner, you will find the solver here in the data. Okay. These are complements of Excel. If not, you can see a YouTube video how to add the solver to the Excel sheet. Probably you have used the solvers later in the past in other courses, so maybe you have that activated. If not, follow the procedure that I just explained. Complements, and here you have solver. You need to hit Go and then accept.
Oh, thank you. There is no.
Another question? So maybe you can try to repeat an exercise with another matrix that we have worked so far. Or maybe you can repeat the exercise with the matrix that you did the homework. You have a homework, okay? So in the homework, probably you can repeat the homework using this Excel. So that could be a small homework. So homework. repeat homework 1, but this time instead of solving it manually, use Excel. Just a small exercise for you to complete at home. What else? What else can we discuss about assignment? What if I have a matrix that is unbalanced? How can I solve this matrix that is unbalanced? So let's say that you have a group. In this group, you have 5 people: Luis, Carlos, David, Ana, and Rosa. And you have to complete some homeworks of design, thermodynamics, operational research, and materials. You see here you have just 4, while here you have 5. And we want to, in this case, let's see that these are the grades that you project, that you can have. If, for example, Luis do the design, he's going to have a very low grade because Luis is not very good for design. And maybe if Carlos do design, he will get a 90. So everything, these are grades over 100. You see, that you as a smart student, you think you will get. So probably one person is smarter than the rest, so you have very good grades, but maybe it's not good at one of the topics. So maybe Carlos, even though he have very good grades in these topics, is not very good at materials. Okay. So you understand that if these 5 people is part of the group, you want to maximize your grades. So let's try to do this exercise. Let's do it in Excel. So let's do this exercise in Excel. So how do we tackle this problem? Let's create a new sheet. So this is the problem that we are tackling. The same, let's repeat. That way we practice. We practice the procedure. Here you have design, thermodynamics, operational research, and materials. And this is Luis, Carlos, David, Ana, and Rosa. Project to have 4, 90, 64, 3, okay. 88, 2, 41, 14, okay, 35, 86, 11, 6, 8, 1, 53. So remember, when we complete these exercises manually, what did we mention? We actually mentioned that we need to balance. Remember, we need to balance the matrix. So in order to balance this matrix, maybe you can invent a dummy subject. So this dummy subject, what's going to be the grade in this dummy subject? Maybe 0, 0, 0, 0 in all of these. Okay, let me think. Yes, I think it's okay. So in that way, right now, this is balanced. And we can repeat the procedure. Remember, you are going to calculate the cost, or let's say the grade, the projected grade. So the projected grade is going to be summa of this matrix this matrix. Okay, but remember that this actually should be ones or zeros or ones. In that manner, this cell is actually calculating the final projected grade. Also remember that here we have to calculate the summation of all of these rows. I need to do the same for all of the rows. Here also I need to calculate the summation of all of this column. I can copy all of this column. In that manner, remember that this value should be 1. So let's use the solver. So we hit solver. What is the objective? The objective is to this cell is to maximize that cell, changing these values, but you have some restrictions. Well, these values should be binary, either 1 or 0. Also remember that these values should be exactly equal to 1. And also these values in the columns should be exactly equal also to 1. So choose one solver and hit solve. So what is the final solution? So the final solution is David, Carlos, do thermodynamics, David, do operational research, Anna, do materials, Rosa, do design, and Luis, don't do anything, just stay there. Do the dummy subject. In that way, you maximize the grade that your group will have. Yes, it looks like Luis is not a good student. Questions? That's the way we solve this unbalanced matrix. you just invent a dummy row. Could be also a dummy column. If you have more rows than columns, maybe you need to invent dummy columns in order to make it balanced. We mentioned that in the first slide. If you have an unbalanced assignment problem, balance and then solve. In the next class, we will see other softwares that you can use. For instance, let's say that you want to solve this assignment. This is a 16 by 16 matrix. You see how this time nobody wants the assignment in the diagonal. For that reason, you have introduced an infinite number in the diagonal, or just a 99, which will have the same effect. So how do you solve this problem? Maybe Excel is going to have problems to solving this, because it's a very big. Actually, it's not big. In reality, you will have problems bigger than this. It's normal to have 300 by 300, 1000 by 1000 assignments. So in the next class, we will use MATLAB to solve this instead of Excel, just to overcome some problems that Excel can have with these problems. Okay, but you have a homework. So for today, we will stop at this point. Do the homework, and we will meet next time. Let me upload all this information in the web page.
Professor, please put the last exercise in Excel. The solution. Thanks.
Questions about this exercise? Here we were maximizing. Okay, complete the homework. I think you will have more questions next class. If no more questions, let's stop at this point and we will see you in the next class.
Professor, sorry, I have a question, but it's about the project.
Okay.
Okay, my question is that you explain us how was the project, and I was thinking to use the queuing problem from the cyber register.
Okay.
Could we use that? Because they work with queues, with one long queue, and they attend.
How many servers?
1 2 people, I don't know. So can we use that problem?
Yes, why not? Yes, that can be an option.
That was my question.
Go ahead. Is there any other question? Okay. So, see you next time. Good luck.
Thank you. Bye.
See you next class. Thank you.
See you. Good luck.
Thank you. See you.
Bye.
See you, Professor. Thank you.